This video is on identifying acids, bases, neutrals, salts, and compounds. So we already know how to look for an acid, and we're going to look for our anions with hydrogen. So the anions we know, we of course know these in the 7th column and the 6th column. Those are all anions, and they can be acids. HF, HCl, HBr, HI. Remember, this column, the 7th column, is a -1. This is a -2 column. So other acids are H2O, which we'll talk about that a little bit. It's also base. H2S, H2SE, and H2TE. Okay? And so we use those two columns to determine acids. So here's another list of polyatomic ions, and these are the oxyions, and as you know, we can put two hydrogens on SO4-2 to make H2SO4. We can do the same with sulfite, H2SO3, sulfurous acid, we're not asking you to name them, nitric acid, HNO3, and we can put, because there's a -1 charge on these, we can put a hydrogen, HNO2. I forgot to mention there's a -2 here, that's why we put two hydrogens on there. And so these all form acids, HClO4, H. Now how many H's should we have? It's -3, so we'll have 3, H3PO4, H, and we should have 2 because it's -2, 2CO3, and acetic acid, HC2H3O2. So those are all the acids, and it's about recognizing the anion in there. If you recognize the anion each time, you'll know it's an acid. So you're looking for those anions that you memorized in 101. And you put the hydrogen with the anion out here. The correct number as matches the charge. Those are your acids. Now, the difference between a strong acid and a weak acid is we memorize the strong acids, which I have in green. And here's one over here, HClO4, H2SO4, and nitric acid. The reason we memorize these, while I only have a few weak acids here, there are thousands. And so if we know the pattern, if we know the strong acids, everything else is a weak acid. And that's how we deal with this. So those are our acids, and that's how we identify them. Remember, an acid is a proton donor, and it has to have a proton to donate every single time. Let's circle some of them here. Here's a proton, 3 protons, 2 protons, a proton, 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 2 protons, 2 protons, 2 protons, 2, 2, and 2, and 1, 1, 1, and 1. So you get the idea on there. A base, how we recognize them, is a metal with an OH. And these are, for us, group 1 and 2. So it's these two columns over here on the right. They have to be, it has to be one of those two columns, and it has to be a methyl. So the type of bases, lithium is a +1. It forms a +1 ion. This column forms a +2. And so lithium combines with hydroxide. Now, if you notice, hydroxide, OH, minus, has a -1 charge, if you remember from previous outcomes in 101. So lithium hydroxide has 1 hydroxide because OH is -1. Sodium, the next one down on the periodic table, it would be NaOH, potassium OH, rubidium OH. These are strong bases. Magnesium hydroxide, there'll be 2 OHs. It's a strong base, but it's not soluble in water. calcium hydroxide, strontium hydroxide, etc. Those are strong bases. So what you're looking for is a metal with OH for us. That's not always true, but in our class, it's going to be true. Those are strong bases, and they're going to come from these two columns over here on the left side, 1A and 2A column. Okay, so a neutral salt is an ionic compound, and so it's a column 1 or column 2 metal with strong acid anion. And so we mix and match. Our strong acid anions are chloride, bromide, iodide, nitrate, sulfate, and perchlorate. And so to make this neutral salt, and to think about it, I'll put a sodium, which is +1, and a chloride together, which is -1, and that gives me sodium chloride. This is not a reaction, but that's how I think about it. I'm matching the +1 and the -1. So what's the formula for, that's a 1A or 2A, let's try magnesium and bromide. The magnesium is +2, so I'll need 2 bromides because bromide is only -1. How do I know that? If you remember, it's in the 7th column, which is -1. So this is 0, -1, -2, -3, -4 when we combine with metals. These are +1, +2, and if we use this column down here, +3. We're not. So magnesium, Br2. Okay? And we can have lots and lots of compounds like this. It has to have the metal from the same two columns, the 1A and the 2A over here. It has to have a metal from them and an anion from a strong acid. So examples of these would be sodium nitrate, sodium chloride, sodium iodide, potassium iodide, potassium perchlorate, and I'm just picking metals from here and figuring out the charge, calcium perchlorate. Now this is tricky because calcium is +2. I know it because it's in a +2 column on our periodic table, and perchlorate is -1, so I need 2 of them. And those are the neutral salts. So we've done weak acids, strong acids, neutral salts, strong bases. Finally, the last one is the weak base, and there's only one of those. The only weak base you need to know is ammonia. And ammonia, NH3, and its Lewis dot structure looks like this. This is ammonia. And when I react it as an acid-base reaction, now down here, NH3, and we'll react it with water, and we get NH4 plus OH minus. And so NH3 acted as a base. It's the only one you have to know of all the weak bases with water. And what happened is this electron pair here, I should do it in blue, come over and grabbed one of them hydrogens. It's really a tussle over who gets the hydrogen. And so we get the Lewis dot structure of NH4, which is positive, and I get OH minus because we removed the proton. And this is the proton that we removed. And you can see it's gone. Remember, we leave the electron pair behind. And here's the electron pair here. Okay? And nitrogen, this electron pair took that hydrogen right here. And that's how we get that hydrogen here. So I should put these two in red. This hydrogen became that hydrogen. So this is a weak base. Okay, remember a base is a proton proton acceptor, hydrogen acceptor. All right, that is all of them. Everything else is a molecule. CH3OH is a molecule. It's a methanol. A lot of people like to say it's a strong base because of that OH, but this is not a metal. All right, that should be everything.